this is the battery box in question. We are going to be unboxing this here soon. I'll tell you a little bit more about it, but the basic is, I believe this is a JAG35. I'm not sure exactly what to call it, but this is a JK BMS 200 amp setup. And these are the cells we're putting in. They are the EVE 280K version 3 with the dual posts. I've had some issues with the dual posts in the past, so I'm going to try to tell you some of the pitfalls that I've had with these, and we're going to go with some of the solutions and workarounds to make these work still pretty well. Just some sort of gotchas you got to be aware of. Turns out my good tripod died. So we're going with a very cheap tripod, and I hope you're going to just forgive me that the camera stays steady enough for this to work. But so what we have here, I bought this off the JAG35 website. They're calling this the AmpBox, DIY 280 amp hour LiPo 4 battery box with JK 16S 200 amp BMS with LED screen. All right, and we're just going to open this up and see how it is. So this is the unboxing experience. See how they, I'm not really big into unboxings these days, but this is to see how they package their stuff. I bought from them before, and the one thing I've always said is every single time I've bought anything from them, it's always showed up about a week or two later than they told me it would. So if you're buying anything from them, just add a week to whatever estimate they give you. So I don't know if this is the version 1, because apparently he's still modifying this design, and this design is still in progress, which is part of the reason why I'm doing this video, is to give my input. So I built a couple of my own battery boxes now, and so I kind of know what's going on. So this looks like it's moved around quite a bit in packaging. So I would say, it's way over here on this corner, that the foam and packaging needs to be upgraded. Of course, I got a fly that's biting me. Right off the bat, this didn't quite work, although I don't see any obvious damage. This did get all the way from the west coast to the east coast. Let's just pull it straight out of the box. Stop messing with all this packaging. Okay, not seeing any damage so far, but I'll just drop it, and that'll ensure that there is. Just kidding. I set it down in a box, and the box sort of folded in. Let's get rid of this. Okay, there it is. See that? I'm going to push it back a little bit, give it a little better view. So that is the box, and I am checking all the corners. Very slight bend on the frame over there. Barely noticeable, and a tiny bend out down here in this corner. If I wasn't looking for it, I wouldn't see it. So it did survive shipping. Let's look at the bottom real quick. And I think he wants it so these things can stand up like this potentially in some version. So I got these feet. This was the screen protector that was supposed to be on the screen. It was attached to the top of the box instead of the screen. And the screen does show something on it. I don't know if that's permanent or not, but let's get into this and see what's going on. The screws seem to be stainless steel screws because they're not sticking to the magnetic tray. Okay, front panel off. So we can get the screw to come out. Alright, so got the BMS here. I'm not exactly sure how it's supposed to be held in place. Now, this did fall forward a little bit on its own, but just on first inspection before taking this off, I'm noticing that the BMS is sort of hanging by a single screw over here. It looks like there's some plastic inserts or something holding this BMS in place, and they have broken off. So I'm gonna let it down gently by taking off the last holding screw. So I think this may have happened during shipping, is that this BMS isn't secured well enough for its weight, and so I think it snapped all of its plastic nylon. Yeah, nylon standoffs. There's some nylon standoffs back here. You can't see it from your angle. Okay, so you see there's that screw up there that's still holding on. Behind that screw, right above it, right, hold on, focus, there you go. That there is the last surviving standoff. So, looks like the rest of them, see this one here, it's all broken off. Looks like it was screwed in. I think, it won't let me focus on it, but there's a white broken off point there. So I think the standoffs are going to have to be beefed up a little bit here. Back plate off. I'm just going to set that aside. Now get to the back of this thing. That's a lot of fasteners. Let's take this lid off. Reminds me of an old computer box. And I see there is epoxy board or whatever on the top of the case just to stop probably anything from accidentally shorting. And this is the PCB that he custom makes that's supposed to make this all easy and quick and DIY and beginner friendly. I do see he's using an aluminum bus bar to bridge this back string of series batteries together. Threaded rods to press the cells, and we have epoxy, fiberglass, some sort of resin boards, and looks like an extra in here. A couple extras. Maybe they're just not stuck down all the way. What's going on? Something's going on. There's a couple of these loosely floating around. There's another threaded rod goes down the center. Okay. That's missing its bolt in the back. Nut. I don't see. So there's a. I can see that here. There's this threaded rod down here, and then the back is you've got this rod here. It's floating in the breeze, and this one here is not, because it's got a nut in the back, and there's no nut down here. PCB way. It says so right here. So this is probably another PCB way printed board here, and I can see that the terminals, the red and black terminals on the front are probably PCBs. It looks like they're PCBs. And to attach the PCB to the PCB, they've globbed it up with a bunch of solder, which hopefully that's just, looks like it's holding on the screw terminals too. So that solder there probably needs to be fairly skookum sturdy to support any twisting force by putting heavy cables in the front of this. I would recommend some sort of back plate here. Back plate or something there. There we go. These are just some zip ties holding this in place. Very nice. Presented exactly probably how it should go. It's got some thermistors up here on top of the batteries. That's good. Oh, he specifies what cells go in here. That's nice. Some information. Oh, so it looks like you can put your own fuses in here. Or these trace fuses. Oh, he's put some trace fuses on here. That's nice. I'm not sure if I knew that. That's a good design. I like that. I don't know what the capacity, the electrical capacity is of the copper in this PCB for how many amps it is. So there is some load handling by the PCB here for the connecting the two series together to make a full set in the back of the PCB. I'm going to just disconnect this BMS. Looks like a couple of connectors. So I've used JK BMSs before, but I haven't used what they're calling their storage. I think they're calling JK BMSs transitioning this style and saying that this is their storage BMS, and the other style BMS, which I was using before, is their EV or mobile battery build BMS. I don't know, like for e-bikes or EVs or something like that. This one's rated for a higher duty cycle, essentially. So this one will be able to run at max capacity for a longer period of time. I think the mobile version is only like 40 minutes or 45 minutes at max. And this one's rated at like 2 hours or 3 hours. I think that's supposed to be the major difference. All right, I can lay that to the side and we can kind of fully see what's going on here. Let me take you off the tripod here and give you the tour. The first video got a little messed up with the overview of the internals of the battery, so I'm going to do another one. We're half built, but we still got everything exposed so we can see everything. We have this compression plate front and back. Plus we have the circuit board. Now, of course, the cells and the bus bars do not come included. I have just installed those, so there's that. But you do get these temperature sensors. I'm still not fond of the location of the temperature sensors, but you do get them. And I have some more coming on the way, so I can route them to where I want them. You get this back base plate back here, this bus bar. It's aluminum. And then you get all the attachments and everything for the BMS. The BMS is there. This one in particular is a, I don't know, flip over, it says on the back what it is. But there it goes. It says a JK. It's a BMS. I believe the 2A stands for 2 amps of balancing, 16S, 16 series, and 200, I think that's 200 amps. That's what we get there. And then we get the front panel. Front panel comes with this circuit breaker. That's installed with a wire and a bus bar on this version. Flip it around so that we see it from the proper view. We do have a brass standoff providing the conductor for the positive here going out to the battery. And we have the front panel, which has a display. We have our terminals here, the screw lug nut terminals with, it looks like this is a PCB on the back. So a PCB back plate soldered onto the PCB front plate. We have all our VMS connections here for all our data. And of course the outside for the breaker, which is 250 amp on this 200 amp model. So that is the overview of basically everything in the box. It does have feet underneath it. I have it stood up a little bit here to get underneath it, but there's feet included as well. So it doesn't just sit on the on its belly. It has some feet there, and you can see that the plate back there, it is removable if necessary. So here's a close-up of the sheared off nylon inserts. So it's actually pretty bad shape. And I found out the screw, the focus, the screw is also a nylon screw. So either the insert or the screw failed. I'm seeing that there's a lot more places that more inserts could be used to attach the BMS to this plate. And I would recommend using all of them. That's what I would do to fix that problem, because I'm going to have to go into town and find some more of these. So we're going to just start putting these batteries in place here. Something that didn't come with the batteries, but will be needed, are these sheets. I don't know if they're exactly needed, but these are separator sheets. So you can put one between each of the cells to give it a little bit of protection, I suppose. And I bought these batteries from 18650 Battery Store. I've bought most of my batteries from them. I get pretty good prices, and the shipping's pretty quick, and they usually have pretty good stock. They also answer the phone and are willing to talk to you, which is important as well. So I got plenty of sheets. And wow, a while. Wow, those cells are the flattest. Now, the last set of cells I got, the version 3 cells, because I have a bunch of the version 2s, the single posts, those didn't swell up at all, and I compressed them fairly well. The last set of these did swell a bit. I didn't have a good compression method in my last battery box, partially why I went with this, because I didn't want to come up with my own battery box again. So we've got some slotted bolts here and here on the bottom, and those look like they need to come loose in order to make enough movement to this plate, because I clearly can't get the 8th cell in there without moving it. So let's gingerly move this away. Okay, another update. These slots need to be moved away from these threaded rods because there's an interference between these two on all corners. So that's another upgrade I would do, is I would move these slots inboard to get rid of this interference. 3/8. So we are freedom units today. Plus I have these threaded rods which are just flat out in the way. Okay, they're not the same size bolt. So the other thing I would do is make everything be the same fastener so we don't have to keep on swapping. It looks like it might be a 10 millimeter. Holy crap, it's 10 millimeter. So that's a 10 millimeter. Yeah, 9 millimeter doesn't fit. So it really looks like that's a 3/8. So the other thing I would do is not jump between standard and metric fasteners. Is pick one side of the pond, because now I need a imperial set and a metric set. I'm going to do the same thing here. I'm going to screw this nut off. Hopefully I don't lose it. And what I'm doing is just tightening the nut back here so the rod can... Oh my god, it's locked into place. So is that one. They're jammed. If I know some open-ended wrenches, that might help. It's just not great, but pair of pliers did work. Alright, I'm going to lose fasteners now. That's alright, I gotta go to the hardware store anyways to replace the ones that never came. There we go. Got enough space. I think it really shouldn't matter. I'm going to put protectors on the back side of these batteries as well. So the batteries have something between the aluminum and themselves. How many battery packs have I built now? Let's see. Well over a dozen. This will be my 4th using EVE cells like these. So I'm getting fairly experienced at it. Alright, so I'm not sure if you're aware, but there's this LiPo QR battery QR scanner app, and this allows you to scan the codes on the top of these cells, and it tells you when they're made, who made them, all kinds of information, production city, what their capacity is rated at. So it's a good way of verifying that you have legitimate cells. It's not guaranteed that these can't be counterfeited, but each cell should have a scannable barcode on the top that should tell you all the information about the cell. And now I can go and scan all these and create a spreadsheet with all these cells. So in the future, I know what cell and where and all that stuff like that. So now I have a scan of all the cells and serial numbers and stuff here. So I think the next thing to do is a voltage test. So we're going to take our multimeter and test to make sure all the cells are closely related in voltage. So I'm just doing a quick cursory test and make sure everything's close to being the same voltage. You don't want to hook up batteries that are vastly dissimilar from each other because you'll get sparking and arcing. These cells, if it's a couple of millivolts or whatever off, it doesn't matter that much. These are all testing exactly 3.3 volts, which is great. It's 3.29, so pretty darn close. This test primarily just makes sure that we didn't get a wild one out of the bunch, because if we find one that's severely off in voltage, that means that something probably happened to it between when it came from the factory and when it got to me. They're all 3.3 volts, so I am good to connect all the bus bars together. So now it's come time to figure out a way to compress these cells. I think that's the next step before putting the PCB on. Trying to reinstall the threaded rod here. I don't think this would be necessary, again, if these rods weren't interfering with the bolts that hold the bottom of this plate to the compression plate to the bottom of the frame, and that those weren't also the same bolts for the feet. Haha. Success. I can't actually compress this fully because I am actually missing hardware. I just remembered. Okay, we're through. I think I can put the battery back in now. Holy smokes. Obviously, I didn't do a very good job of inspecting my cells. But I have a spare. I'm going to use it. Oh, this one's got damage too. This one's good. Well, now I'm going to go back through all the cells and check for damage. Yeah, so I've got 2 damaged cells, and it definitely looks like it was done in shipping. This one's not so bad, just a little bit of a dent. That's not, as I understand, these cells are not too much concern, but this one's pretty whacked. And the case is pretty bowed and stuff in there. So that's quite unfortunate. I'll call up 18650 and see if they would be willing to do something about the damage there to those cells. So let's put these extra sheets up front here. Added insurance, meaning fasteners going into the batteries. Is there better access? Nope, the back's got the same problem as the front. There's no way to just get a simple freaking driver on that. So I'm gonna go find an open-ended wrench. So I went to go get an open-ended wrench and then realized that an open-ended wrench doesn't work because I have this tool here which tightens things, and this particular one just works to 6 Newton meters, which is the terminal torque for these batteries. It's a Presca cycle. It's a bicycle tool calibrated for 6 Newton meters, which is basically exactly what you need. I will also compress these cells at about 6 Newton meters as well. I think actually the compression should be slightly less than 6, but I don't have a torque wrench that goes anything less than that with me at the moment. I think the primary one is the battery terminals. You don't want to over tighten these because Well, I'll get into that once I get into the terminal thing. But to get to this problem is I want to drop these bolts down temporarily. I'm just going to put this spacer, try to put the spacer underneath the whole battery. So I can let these feet drop down a little bit and hopefully I'll get enough clearance to get to those bolts. Come on. So that's 6 nanometers. So I'm going to go to 6 and then just back it off 1/8 or 1/4 of a turn. And I'm going to consider that to be compressed. That's 6. Back it off 1/4 turn. I think the proper torque is somewhere around 4 Newton meters, if I'm not mistaken. I'd say my last time I built my last 2 batteries, I thought I had enough compression on them. It turns out I didn't, because it did swell. Not that swelling is that big of an issue. Swelling just means that instead of the 6,000 cycles you can expect out of the batteries, you might only get 3,000. You know, so 3,000 life cycles, 3,000 cycles off of one of these batteries, especially with the easy life that some of these storage type cells are going to have, is still probably going to exceed the calendar aging of the cells themselves, and they'll probably still die due to calendar aging before they die due to cycle from being overcycled. Okay, here's where we're at. I had to take the batteries back out to drill the plastic out of the holes, I guess, that the nylon inserts left. I went to town and I was unsuccessful at finding anything that would work without a lot of modifications. I could make up my own standoffs from scratch, but Amazon will get the right ones to me in 2 days, so I think the nylon inserts, the standoff is a great idea, but I count 1, 2, 3, 4, 5, 6, 7, 8 mounting holes for this BMS, and there's only 4 tapped hole locations. I placed the BMS up here to look, and I don't see any other tapped, drilled, and ready mounting holes for this thing. I thought about drilling some more and tapping some more, which I think I probably should do. That's a lot of weight for 4 plastic screws. I was measured, so I couldn't possibly get the drill bit far enough to hit the next battery. So I'm stupid, just not that stupid. Okay, so I took the BMS off, and I managed to get a couple of threads in that hole, and that one tapped okay once I removed the BMS. Cleaned all the shavings out of it. I've got the hardware back, so we can now tighten this whole pack up. Make sure these are all in line, and get to installing the PCB on top. Alright, so I have tightened this up to 6 Newton meters and backed them all off. I'm seeing that this plate is slightly bending, so this is definitely maybe a full turn backed off from 6 Newton meters. Like I said, I think 3 or 4 Newton meters is probably. In fact, I might back these off a little bit more. I wish I had a torsion tool that was a little bit less, but this is the lowest I've got. What's making me nervous here is that this top piece of, I don't know if you see that there, but that's bending this piece of fiberboard or epoxy board. It's got a little bit of a that way direction to it at the top, which means there's a lot of force being pinched right there. I don't think that's much of an issue. I think we don't need 6 Newton meters, which is what I never intended to leave it at, so we'll just call it what it is and move on. So here's what I'm finding about these cells, at least my issues with the terminals on these cells. And I've talked to a couple of the manufacturers, our distributors, and 18650 and the like, and they've said that they've reported other customers having this issue as well. And it comes down to these terminal tops. Now, the dual posts have a greater surface area, which in theory should give you a better current handling capacity on these tops. But because there's so much more surface area and it is aluminum, what tends to happen is that you need to increase the clamping force on these to ensure that there's a good connection, and you can only put 6 Newton meters of force on these, and that, to my opinion, that's not quite enough to ensure a good connection all the time. I'm on a boat in the marine environment, so maybe my situation is worse than most. What tends to happen is that I think aluminum oxide or something develops on top of these terminals, and you start getting these weird voltage readings throughout your pack, showing that cells are bouncing all over the place. The solution to that for me has been taking the terminals off. Retightening them hasn't helped. Taking the terminals, the bus bars off, sanding down the tops, reapplying the bus bars, and then the problem goes away. I'm going to put a little conductive grease in my pack, or at least I did, to see if I can further get rid of this problem. It seems to be not that big of a problem. Not a lot of people are experiencing it, but I think some people are. The other thing to note about these cells is that there is a helicoil, essentially, inserts. I don't know if you can see that in there, but there's a stainless steel inserts in the tops of these batteries. And the gotcha with that is that if you have a bad connection to these tops, and the helicoils are providing all of the current handling capacity of the battery, what tends to happen under the worst situation is those helicoils will weld themselves to the terminal screws, and then you got a terminal screw that's welded in here, and that makes a hell of a mess to try to pull out and then clean up and then reuse the terminal. Getting those helicoils out and everything and retapping it, it's a nightmare. But so the lesson is to really make sure all your batteries are tightened to the proper specification. Over tightening them is bad. I've taken these up to like 8 Newton meters and then started ripping things out. So 6 is really the proper torque. I wouldn't go any higher than that. But I would just make sure that these terminal tops are nice and clean before you put them in your pack. That's essentially the lesson learned with my previous packs. And once the terminals have all been finished and taken care of, I've not had the issue since. So that's the gotcha with these particular cells. And also it leads into the particular why I don't like aluminum bus bars and aluminum connections, is because you have to be more careful with your connection to connection, especially with dissimilar materials, just because weird interactions can happen and you'll end up with these bizarre, strange things. Anyways, that's it for this. Continuing on with the build. We're going to fix these. We're going to prepare the terminals. So now I got some fine grit sandpaper. It's like 220. I'd like to go a little bit lighter, but had more, but that's what we're going to use. So we're just going to lightly scuff the surface of all these terminals, and then we're going to wipe them down. Just hit it like that, and we're just going to go through all of them. A little isopropyl alcohol down, get any of the aluminum dust out of there. We don't want to make a lot of it, because the more dust we make, well, let's just say the aluminum dust doesn't help anything. Exciting, I know. Okay, what I have here is some carbon conductive grease. This stuff should promote the electrical connection between the terminals and the bus bars, and hopefully also prevent any sort of oxidation or corrosion that was developing on my terminals from my previous build. Take you along for the ride of what I'm doing here. I'm just taking a little piece of sandpaper and I'm gonna rough up the terminal. There we go. Take a little towel with some isopropyl alcohol on it. Clean it off. Okay. dab here. I'm using a little ice cream sample spoon to just spread it on. The idea is, you don't need very much. The purpose of this stuff is mostly to make a good connection and stop the aluminum from oxidizing. And all the battery terminals are done. So hopefully we can get to putting the PCB on. It's getting quite late, but we're going to keep on keeping on, I guess, and move on. So now we should be able to just set this on top, but once we set this on, we're going to make a mess. So I'd like to not move it too much more than I have to, not that it's super critical. It's on there more or less. Just wondering why these terminals for the sensors are backwards facing. Oh well, matters that much. Let's see how these are coming out that way and these are coming out this way for some reason. I don't know why. So I got some of the flexible copper bus bars. That's what came with these batteries. I think they're standard with 18650's orders now, as these flexible coppers. They're pretty good. This is where the user-friendly aspect comes in this design, which I appreciate. I think this is kind of neat. I like this idea. I like the concept a lot. There we go. And we have the messiest battery build you're going to see on YouTube, I think, because I haven't seen anybody else apply this thermal conductive grease on a battery build before. Most companies will just buy the batteries raw, and then they will weld bus bars to them, and that's how they'll build a pack for a perfect connection. That's how you get the best connection. Although it means it's less serviceable, but it is a solid guaranteed connection. All right, well, now we're getting close to the end. So what I'm doing is just doing the final torque. If I was smart, what I meant to do before I started this was tape this up with electrical tape. There was no metal exposed, more than there had to be, but I've been keeping both hands on the tool at all times so that I don't drop it. And this is just torquing everything up. And I think we're going to be done for until we get the rest of the parts. My advice is either find a way to cover the battery so you can't drop something across the terminals. Make sure the tool is fully insulated, and keep both hands on the tool at all times, because shorting this thing out is a disaster. I'll just do a spot check here. Should be good. So now we should see 48 volts across this pack. 52.6 volts. So that's a good sign. The other thing I'm seeing that I really don't like about this PCB is these thermistors. I really wish these thermistors were plug-inable and that they had some slack on it so I can put them where I want. Because I'm taping them to the PCB up here. Doesn't make a lot of sense to me because it should be battery sensor. So there should be taking the temperature of the battery. Unless there's some sort of logic someone could explain to me why they're just taped randomly to the PCB in these places. I don't get that. I think it's a very novel design, and I'm interested to see what the longevity and if there's any problems arises from this particular setup. It did make putting the bus bars and putting the terminals and this much faster than a battery. Having this all wired up makes things 1,000 times faster. I would probably probe all these out and just confirm that they are correct before plugging them into the battery. BMS, obviously we had a failure of the BMS dismounting itself in shipping, and we did see that the box had shifted quite a lot in its packaging during shifting, so it did get a little bit of a rough ride here. And so we're looking for more mounting hardware for the BMS. I don't like that there isn't a fuse built into the battery. It's just a circuit breaker that's only just on the positive. There's not one on the negative, just the positive. So a real circuit breaker, a real breaker for this kind of battery, providing this many amps, should be on both the negative and the positive, and it should be a lot beefier than what I'm seeing here. I don't particularly care for the way that this, I don't really know. It feels all right, but this is really more of a disconnect, really more than a circuit breaker. That's how I'm going to treat that. I don't like the stud screwed in here. I don't know why they didn't just put a ferrule or something on the end of this, or just directly put it into the circuit breaker. I don't know what this standoff is being jammed in here. I don't particularly care for that, so I might change that. There's this aluminum bus bar in here. I think he's already mentioned that this probably needs an upgrade or a little different change in design, and I don't think this is quite skookum enough. I would like to see some sort of backing here to support these terminals, just in case they're going to have very heavy cables potentially on them. Someone can jerk them over time. They could work their way out, and hard solder connections between this have a tendency to fail over time. So I don't particularly like that. I would like to see dual wires if I could. I don't know he's planning, I think version 2 is planning to get rid of these wires and go with just bus bars everywhere, which I don't know, I'm not that big of a fan of. Depends on how they are coated and how they're routed. He's probably going to go with aluminum because he's always gone with aluminum with everything else. I'm not a big fan of aluminum. I prefer if they'd be copper, just because I don't like all the dissimilar metals. Problem is you have all these expansion coefficients that are different between all the different dissimilar metals that we're using for all our connections, and they're all over the place, so power and heat cycles over years might loosen something up, and you just have different resistances involved. I'm sure it works fine in the short term. I just don't know the longevity of such a system. I do like the PCB panel. I do like this. That's an easy, nice way to do that. I think this is a good design. The box seems to be a fairly decent design. I would just change the clearance of these feet to get them away from these threaded rods going through, and make sure that these feet were moved inboard a little bit, just to give us a little clearance, because that was a nightmare. I still have it propped up a little bit just so I can get underneath it and move these feet around. Let's see. I like the handles. Yeah, I think this is a pretty good first version. I do want to see some upgrades to it. I don't think a lot of those would cost anything more. I think a little bit of extra wire on these thermistors would, I think that's small things. Copper bus bars, obviously that's going to cost more money. Could be maybe that he offers that as an optional upgrade, because some people, probably figure it doesn't really matter. Mostly, if I had the preferences, I would any additional money that was paid for the screen, I would rather into a beefier protection system. And like I said, I would favor a fuse. Anybody who's building a BMS or a battery like this should have a big beefy disconnect somewhere to the battery. It's nice that there is a disconnect on the battery. I think that covers most of everything I've discovered so far. So hopefully, when we get the mounting hardware for the BMS, it should be a real quick job of slapping that in and booting the thing up and getting to rock and roll. I'm being a little harsh with my review on this, but that's because that's how we improve things, is by criticizing and offering ways of improving things. I think it's a good first try, but I do think it needs a little bit more time in the oven, a little more time to bake. With that said, I'm calling it a night and going to bed. I'll see you when I have more hardware. So I have the replacement hardware. And of course I already tapped and threaded some more holes, so we should have a little bit more strength. These are M3, and I'm hoping this is gonna do the trick. So these are going to need to be trimmed off a little bit because they go too deep. Carefuling. Probably the smarter way to do this is hold this up to the case and flush cut it off. That way we get the correct depth. Okay, let's see if this all lines up. Should. And that should do it. Oh yeah. That feels much many more steadiers. Much more betters. So I'm at the point in time where I can start hooking this all back up. My thought is that I might want to make additional cabling here. This cable that they used is not a bad cable, but it's not as flexible or as high quality as you can buy. And I might just replace it. This wire is a little bit stiff to make that bend. If we went with, here, let me go get some. Be right back. So this is the wire I'm talking about, the silicone wire with, now obviously it's a little thinner gauge. So this wire must be, I thought it was 6 gauge before because it's an 8 gauge. It's probably 4. I'm going to guess that that's probably a 4 gauge wire. But this wire, if you can see, can just absolutely bend over on itself. So I was looking around at all the wires, and as long as I have to see if I wanted to replace this or not, and it turns out I do not have the right gauge wire to replace this, but I do have more copper, I have more bus bars, and I was just looking, that looked really close, and what do you know, that fits. So I don't know, I kind of like this. It's stiff enough where it's not going to come in contact. It's already insulated, and I know it's rated for 200 amps. Kind of novel. But the proper gauge wire, if you wanted to use 2 of them, would be 2 6 gauge wires, and this should be a 2 gauge or greater. Ideally, if it was a 4 gauge, it would probably be fine. The only thing is, it does leave this, you know, there's 2 terminals here, and these terminals are meant to share the 200 amp load. I don't know if one of them by itself is designed to handle the full 200 amp. All right, mystery solved. I have found out that this is a 4 gauge wire equivalent. It is 25, that's 25 square millimeters. So that roughly translates into about 4 gauge. So as the wires back installed there. I believe these only go in one spot, so don't have to worry about inserting them in the wrong place. Now I have to connect the wire to the positive for the BMS, and we should be able to actually turn the BMS on at that point in time. We don't actually need to connect anything else just to see this thing go. So maybe we'll do that. That's just a power cable for the BMS, so that doesn't need to be anything special. And what do we have here? There is one more. Ooh, we need the battery turn-on wire. I had to review the footage to figure out where that went, and it went, well, right there. Okay, so I think we should have to hit the on button, and we should see lights and stuff and beeps, and oh my gosh, what a pretty interface. It's in Chinese. There, that's easy. Okay, cell voltages. Interesting. All the cell voltages are reading a little bit lower than I think what my multimeter does. when I tested the cells, yeah, I'm getting 3.3 volts when I measure a cell, and these are coming back at 3.28. I'm getting 3.3 volts, just so you can see. I think you can read that, but I'm getting 2.85 volts. And 3.3 on my meter. So I have to figure out, there's another cell. There's another cell. So we're gonna have to figure out what's going on there. That ain't right, it's no good. No good at all. Let's just connect it to the app and I will do some investigating. Be right back. So I just looked it up, and it looks like there's a calibration voltage for the entire pack, and that will set the voltages correctly on the BMS. I've never had to do this before with any other JK BMSs, and this will be the 6th or 7th BMS from JK that I've owned, and I don't remember ever having to calibrate the voltage. So out of the box, it doesn't read the right voltage, so that's no good. I don't particularly care for that. I don't know why that would be necessary. If anybody has an explanation as why the voltage needs to be calibrated on a JK BMS out of the box, let me know in the comments. I have bought some more temperature sensors. Hopefully they're the right ones, and I can just plug them in and route them wherever I want. They were only a couple of bucks. I think it was like 5 or 6 of them was like 10 bucks or something like that. Okay, so I think I'm only going to replace 2 of the temperature sensors. This one I'm going to keep because I like that it's on this piece of the PCB here with the copper. Maybe I'll swap out this one and this one, and we'll leave the other 2. Well, it's a 10K thermocouple or a 10K resistive sensor. And it is registering the temperature just fine. Okay, so here's what I've done. I've taken one temperature sensor and just ran it to the side of the battery. And the other one, I snuck down in there and placed it on top of that cell next to one of the terminals. And then we've got this one connecting to one of these copper planes on the PCB, and this one's just attached to well, just the PCB itself. All right, just checking these connections here. God, I don't like this. Yeah, you can't do this. I can't even get enough torque on this to tighten that down properly. Wow, that's kind of scary, putting that kind of torque on that thing in there. So we're going to just screw this back up here like this before attaching the main positive, and then we will be fully live. This is where I get a little nervous. So, hey, the nice thing about this black stuff you put on the batteries, it gets everywhere, and it makes great drizzling on top of ice cream. I highly recommend. I'm going to get this stuff off my face. That's better. The next thing to do, which is pretty much the final thing before buttoning this whole thing up, is to connect the positive. Okay, so we should be all energized now. It's a matter of getting the front cover back on. It is a very pretty install once it's all said and done. It looks for a very nice package. There's another company that kind of does this thing. He's got this epoxy sheet on the glued to the top lid. There's another company that makes battery boxes that just puts the epoxy sheet, and it just sits and rests. You put it on top of the cells before putting the top cover on. And I like that idea more because you can drop that epoxy sheet protecting all the terminals in place first, know that everything's protected, and then drop your cover over the top. That way you can be assured that if you don't accidentally, while you're doing this with the cover, you don't put it on an angle and cross 2 connectors together and get an arc. There's no backplate. Got that around here somewhere. Oh, here it is. Okay, tiny hands and much cussing was involved, but the backplate is on. So let's button this up. Hopefully, for the final time for this video, there she be. Now we've got a zillion screws, which I don't think I'm going to put you through. All right, so I've got an inverter here. That's AIM's power inverter. And I've got a couple of resistors here, 10 watt, 10 ohm resistors together, so that'd make 5 ohms, so we can pre-charge this sucker, because this thing gives off a nasty spark. Yep, 52.7 volts coming out of that. So what we shall do is attach this to this. Okay, that should be good. Go ahead and shut that back off. No sparks. That's what we like. We're doing as much high voltage and batteries. I sure get jumpy at this shit. It's on. Let me go find something to plug into it. So we got ourselves a 600 watt little heater. Go ahead and yeah, I was getting a bit chilly, so I'm happy it's working. And we see 8.8 amps of draw on it. I'm just gonna sit here in front of this little heater for a minute and just enjoy it. Don't mind me. I'm just gonna stand here. Okay, today let's talk about batteries. This is going to be sort of the wrap up and conclusion of this video. Because I've had a little bit of a think about it now, and I've got my sort of thoughts. Overall, I'm going to give this battery a C+. Some of the things may have just happened to me, like the shipping, dismounting the BMS, and other things just need improvement. I made things a little bit more difficult for myself by resurfacing the tops of the batteries. The other thing I want to note is that I torqued these things originally. I didn't keep them torqued down for more than a second, and only one at a time, to 6 Newton meters for the compression of the batteries. I knew that was way too much. Turns out it's quite a bit too much. I sort of knew this, but I thought that the torque was around 3 or 4 Newton meters. Turns out it might be around 1 or 2. So that's not good. So a way to fix that would just be to put some labels on the bolts back here, just to mark them as 2 Newton meters, which I think what he said in his video, they should be done. The other thing is I didn't have a torque wrench. I do have a torque wrench, it's just not here with me on this property. But I did see that there is some 3D printable torque wrenches that work fairly okay for between the 1 and 3 Newton meter range. You can just download off of printables or whatever. I would sort of recommend, if they could, printing some of those and sending those with the box so that you have a torque meter with you. And I think a 15-cent 3D printed torque meter that got you through a couple of bolts would be a great improvement. 6 Newton meters, once you get over 5 or 6 Newton meters, a lot of torque wrenches sort of start there. So your more basic torque wrench will get you by doing the tops of the batteries, but the 1, 2, 3 Newton meter range is kind of a harder to find easily. You have to buy a special torque wrench just for that range, and I don't think a lot of people are going to have it. I sort of knew what range I was looking for, and I screwed up, so I could see other people screwing this up. One of the other things you could do is, if you printed your own torque tool, is you could make your own fixture with the 300 kilograms of force supposed to be on these batteries, and you can tune that 3D printed torque tool to match the threaded rod setup that you have built into this battery box, and then you know you're in the right torque range. It's not really a guess, and you don't have to worry about the math. So that's sort of wrapping up my build. Now, what I think about the overall battery, well, I'm going to give it a C+. And the reason for that is for a couple of things. I think the main issue is these threaded rods at the bottom. I know in his video he says you'd be able to get through the back, but there's still a clearance issue in the back to tighten the plate from the back. And my plate was pushed all the way in, so there was no way without taking and loosening up the feet to get the correct number of cells in there. It was just too short, and I had to undo the bolts and widen the compression plates apart. There was no getting around that. So in his video, you don't really have to take this plate full off, but of course I did because the battery dismounted itself. I was missing fasteners, and the plates were too close together, so I couldn't get the batteries in without dismantling it. And then remantling it obviously makes a lot more time. So it goes from like an hour-long build, probably would have taken me 2 or 3 hours if I hadn't run into having to go into town and getting fasteners and stuff like that, plus the additional hour and a half I did with resurfacing and putting the conductive grease on top of the cells. So for me, what should have been like an hour or 2 hour build turned into almost a 2-day build. Part of that's because of recording and things like that. And the cost. I will put the cost down here because I think we're right around, with the batteries and everything all in, I think I'm in the $2,000 range, which puts this as a pretty affordable pack. Very, very price efficient. So that's great. The overall concept and of this battery I really like. It's USA made, so that's going to help with some people. I think more labeling and more information printed on the PCB or just labeling all throughout the thing would help with the build process. I don't like the screw terminals, but I think he's already upgrading these. They're exposed, and I don't quite think for 200 amps. I'm not sure. They might be sturdy enough. This just might be just me being picky. I don't like that. I don't particularly like the... Let's see if I've got one here. I took one out. I don't like this stiff wire they're using here. I think the silicone, finer copper wire, this isn't that unflexible. This is actually pretty good when it comes to flexible wires. It's actually really not that bad, but there is better. Also, I think the gauge needs to be upgraded. The connection to the BMS and everything like that, I think you really need to use both the posts on the BMS to get the 200 amp rating. So I would like to see using both posts on the BMS. I really don't like the breaker. I don't like the breaker setup. I don't think this breaker is capable of handling 250 amp disconnect. I think this is really just a disconnect for servicing. I don't think this is really a breaker. And I'd like to see a fuse. But they're just a good safety to have, that just absolutely everything else fails, the fuse will go. Because I think the main line of defense right now is the BMS, and under certain circumstances, the BMS might fail at shutting the battery off or something like that. And BMSs tend to have a habit of sometimes failing not safe. They fail poorly. They fail open rather than closed. And then that gets you into a situation where you have a battery you can't turn off. And especially if this could fail too. I think we could do a little better. Since this is a safety device, this is the one thing I wouldn't skimp on, is this here, because I'd make sure that something in this battery was bulletproof, safe-wise. Also putting the brass stud on the top of this circuit breaker, I'm going to call it. I don't like having all the dissimilar metals, because all the torque settings get funny, and different metals react different ways over time, and different forms of corrosions, and different forms of expansion, heating, contraction from the heat cycling of all the different metals. So I try to keep all my bus bars and connections the same type of metal. I'm going back and forth between copper and aluminum all throughout this. I don't particularly like that. Copper is great. Aluminum can be fine, but you gotta remember that aluminum oxidizes, and you can get an oxide layer or something build up on those bus bars that can make for bad connections or weird connections. And so you just have to make sure your connections are good with aluminum. You just have to be a little bit more careful. I think that covers a lot of it. I personally don't need the screen myself, so I would forgo the screen for more safety if I had the choice. Other bit of tip when putting this battery box together is if you just hand thread all these fasteners all the way around the box, every single one of them, don't tighten a single one up, just 2 or 3 turns in, you'll be able to get the cover back on. I wasn't able to get the cover back on very easily until I made sure everything was very loose and every fastener was in place before I'd start tightening anything down. And it's really critical. The other thing I ran into that was odd is there's some screws that are short for some reason. Make all the fasteners the same. Going back and forth between metric and standard inside the box is kind of not great. What's great about it is solid. It's beefy. It's a great packaging. I think it's a great design. It's simplistic, but still could be the potential of being pretty robust. Of course, I didn't like the thermal probes either. I relocated some of those. So I'd like to know why those are just stuck to the PCB. That doesn't make a lot of sense to me. But the PCB overall I think is great. It definitely simplifies the install quite a bit. I think that pretty much covers most of it. That's quite a long-winded final review of this video. I'm sorry for the length, but here we go. Have a good one. Just one last note. I didn't make this video to be discouraging because I actually really like this concept and I want it to succeed. I'm just trying to improve it the best I can. And I know I'm going to make some improvements to this battery for my own purposes. And I hope that they continue to improve this system because I think this could be fantastic with some tweaking.